Hello, today we are talking about motion. So we're revisiting what we already know. So again, there's nothing really in this that's new, but it's a really, really great refresher. So we're going to talk about a couple of things. We've got 3 topics that are already we know and we need to keep them straight. But the first thing that we have is position. So we're usually given a position function, a position graph, but we have a position. And this is going to be the location of a particle, or whatever we want to call it, but the location of a particle, and it's usually, I don't know how to spell particle, sorry, on the x-axis. So my particle is moving on the x-axis, moving left, moving right. So that's what x represents. Then I have the velocity. Now, the velocity is the rate of change of position, so that is going to be the derivative of my position. It's the rate of change of the position. And that is just going to be the direction. And when I say direction, I mean positive direction means moving to the right. Negative direction means moving to the left, as well as the speed of the particle. And finally, we have acceleration. And again, acceleration is A, and it is the derivative or the rate of change of your velocity, which, if we talk about position, it's the second derivative of the position. And this is acceleration, or how fast the velocity is changing. So again, these are the 3 concepts that we have in motion. We've got to just keep them straight and know when to use what. So moving on to answer these basic questions. So x of t is the position of a particle. The following statements are true. So initially means what? Something's equal to 0. What is equal to 0? And that's time or t. So you can write time in there, or you can write t. So either write the letter or the word, whichever you prefer. At the origin means what is equal to 0. And because our particle is moving on the x-axis, that means x is equal to 0. You could have written position. Now at number 3, at rest means what is equal to 0? Well, if something's not moving, that means the velocity is equal to 0. So number 4, if the velocity of the particle is positive, then the particle is moving to the, okay, so if the velocity is positive, that is like the derivative being positive, which tells me my function would be increasing. And increasing, when my object is on the x-axis, means that the particle is moving to the right. If the velocity of the particle is blank, then the particle is moving to the left. That would mean the velocity of the particle is negative. Number 6, to find the average velocity over a time interval, we divide the change in blank by the change in time. So the average velocity is just going to be how far did I travel in a certain amount of time, which means it's the rate of change of velocity by the rate of change in time. Number 7, instantaneous velocity is the velocity at a single moment or instant in time. Number 8, if the acceleration of the particle is positive, okay, acceleration, positive, then something is increasing, and that something is my velocity. Okay, so if my acceleration is positive, that means my velocity is increasing. Think about your car. When you put the pedal to the metal, so to speak, you have a high acceleration, you have a positive acceleration, your velocity is increasing. When you put on the brakes, your acceleration is negative, and that means your velocity is decreasing. Number 9, if the acceleration of the particle is blank, then the velocity is decreasing, and that's when the acceleration is negative. Number 10, in order for the particle to change direction, the blank must change signs. So in order for something to change direction, first I have to slow down and come to a complete stop, and then go in the opposite direction, which means my velocity must change signs. Number 11, one way to determine total distance traveled over a time interval is to find the sum of the absolute values of the differences in position between all resting points. Okay, that sounded terrible. We're going to go ahead and do it though. It's really not that bad. And I'm going to ignore this because I think I'm going to have to write over top of this. So I'm just going to cross it out now. Sorry about that, Dixie. Okay, so what we're going to do is we first need to find out where does this object turn around. So this thing could go like this and then turn around and go back this way and then turn around and go back this way. And I need the length of the entire like string. That means the total distance traveled. So it's not how far away I am from where I started. That's displacement. So start with my position, which is right here. And I need to find where does it stop. And that is where my velocity is 0 here and here. I've made up that graph, by the way. So let's find our velocity, which is going to be my derivative, which is going to be t squared minus 2t minus 3. And I really want to know where's the velocity equals 0. So I solve this and I factor t minus 3, t plus 1, I believe. And I find that t is 3 and t is negative 1. Now we were given a time interval and that was between 0 and 6. So obviously we don't have negative time, so we don't care about that. So now we're going to get to that thing of absolute values of the differences in position between all resting points. Okay, what that means is I'm first going to find the position at time 0. That was my starting position of time right here. I'm going to find that. Then I know the object stops and changes direction at time 3. So I'm going to figure out, well, where am I at time 3? I'm going to figure out how far this particle traveled between time 0 and time 3. Then the object changed direction and continued on until the end of the time interval, which was at time 6. So I'm going to find that position and figure out how far the object traveled between 3 and 6. So recap, I'm going to find the positions. I'm going to find how far did the particle travel here and how far did the particle travel here. So first let's find x sub 0, and x at 0 is just 4. X at 3, I'm going to have to do some calculation here. It's going to be 9 minus 9 minus 9 plus 4, which is negative 5. So I can stop right now. How far did the particle travel between time 0 and time 3? Well, it started at position 4 and it moved to position 5. So I know that this distance that the object traveled was 9 units. I don't believe I have units. Okay, so 9 units. X at 6. So I plug that into my calculator and hopefully I did it right. I got 27. Sorry, 22. So then I need to figure out, well, how far did the object travel between negative 5 and 22? That total distance traveled there is 27. So between time 0 and time 3, the object traveled 9. Between time 3 and time 6, the object traveled 27, which means the total distance traveled is 36. Units. Typically we would have some units and we don't have them on here, so I apologize. Okay, if you need to write some more things down or any questions, pause the video here as I'm moving on. So worksheet 2. We now have a table. The data in the table has selected values for our velocity. We have units here, meters per minute, of a particle moving along the x-axis. And the velocity is a differentiable function of time, which means I can take the derivative of the velocity. So easy questions, don't make these too hard, they really aren't too bad. So at time equals 0, is the particle moving to the right or to the left? Well, I determine that by finding the velocity at time 0. The velocity at time 0 is 3. And I don't care what the number is, I care that it's positive, which means my particle is moving to the right. So the particle is moving to the right, and we know that because the velocity is positive. That's all we need to say. If you need more time to write, pause the video. Number 2, is there a time during the time interval from 0 to 12, that's our entire table, when the particle is at rest? So is there some time when the particle is at rest? I'm going to apologize right now. My screen, video screen, does not show that this is a negative. I am so sorry. I just looked at my table. It shows that that's a positive. So what I have written is completely backwards. So v of 0 is negative 3. It's a negative. And the particle is moving to the left because the velocity is negative. I apologize. I didn't check to see that the table fit. There you go, much better. Sorry, on to question 2. Is there a time during the time interval 0 to 12 when the particle is at rest? The particle is at rest. That means my v is equal to 0. So the question is, do I know without a doubt that there is a time when the velocity is equal to 0? Well, if velocity is a differentiable function, that means velocity is continuous. So v is continuous and differentiable. Okay. Which means we get to use our intermediate value theorem. So I know that v of 0 is negative 3, and I know that v of 2 is equal to a positive 2. By our intermediate value theorem, because v is continuous, somewhere between time 0 and time 2, my velocity's got to hit 0, or this isn't continuous. So by intermediate value theorem, there must exist a time c, I don't know, where c is in between 2 and 0, where v of c is equal to 0. There we go. So our velocity changes from negative to positive, has to be continuous, which means somewhere our v has to be equal to 0. Number 3, use data from the table to find an approximation for v prime of 10. So v prime of 10. I'm writing v in green, and it should be red because v prime is acceleration. So v prime of 10 is the derivative, which is just a slope. It's just a slope. The derivative has always just been a slope. So when you go back to your table, I want to estimate the slope of my velocity at 10. Well, I don't have 10 in my table. Well, what I have is I've got values of the velocity at 12 and at 8. So I'm going to use those two values. I'm going to subtract the y values and divide by, subtract the x values. So let's go ahead and do that. So that's going to be v of 12 minus v of 8 all over 12 minus 8. So my time is on the bottom. I can put my units in. I think I had meters per minute. And my derivative is actually going to be meters per minute squared. Sorry. So here we go. We have v of 12 and v of 12. Hold on, let me look again. V of 12 was 5. V of 8 is 7, and 12 minus 8 is 4, giving me negative 2 over 4, which is negative 1/2 meters per minute squared, as this is an acceleration. And it says explain the meaning of this. So acceleration of the particle at t is equal to 10 minutes is approximately negative 1/2 meters per minute squared. So number 4. Let A of t denote the acceleration of the particle. Is there guaranteed to be a time t equals c in the interval between 0 and 12 such that the acceleration is equal to 0? Justify your answer. So let's look at our table. Moving back to my table. So the question is there a place where my acceleration, which is my derivative, is going to be equal to 0? Well, let's take a look. So my velocity goes from -3 to 2, so I'm increasing. And from 2 to 3, I'm still increasing. From 3 to 5, my velocity is still increasing. From 5 to 7, I'm still increasing. And then from 7 to 5, I'm decreasing. Which means I could possibly have a max there. I don't know that for a fact. But the key is the velocity is 5 at time 6. The velocity is also 5 at time 12, which means somewhere in between time 6 and time 12, the derivative has to be equal to 0. That's your mean value theorem. So I'm going to scroll down and we're going to explain this. So the answer is yes. And by the mean value theorem, v of 6 is equal to 5, which is equal to v of 12. Now let's find our slope there, which means my slope, which is going to be v of 12 minus v of 6 over 12 minus 6, which is going to be 5 minus 5 divided by 6, which is going to be 0, should be equal to v prime of c, where c has to be between 12 and 6. So that's our mean value theorem. So we know that there's a c that exists that meets this condition. So therefore, yes, my a, which is my v prime, will be equal to 0. Moving on to example 2, our graphical example. So here we have the velocity. Again, this is velocity. And hopefully I'll get my numbers right because the numbers are really hard to read on the screen. I apologize, but every tick mark is a 1, I believe. So at t equals 4 seconds is the particle moving to the right or left. Okay, particle moving to the right or left, all I care about is v positive or is v negative. So that's all I care about. So let's look at v of 4. And v of 4 is this number here, 1, 2, 3, 4, 5, which is 6. So v of 4 is 6. I don't really care. It's positive. So v of 4 is positive. So particle is moving to the right. Quite simple. That's it. There's nothing else to it. Number 2, over what time interval is the particle moving to the left? Okay, particle moving to the left, that means v is negative. So all I care about is where is my velocity, which is the graph I'm looking at, where is that negative? And that's happening all right here. So that is between, looks like 9, it ends at 9 and it starts at 5. So t between 5 and 9. Sorry, I need an equal sign at 9 because technically it is, sorry, the velocity is negative at 9. I don't need an equal sign at 5 because at 5 the velocity is 0. So here's my interval, and I know that the particle's moving to the left because the velocity is negative. Now, number 3, at t equals 4 seconds is the acceleration of the particle positive or negative? So for the acceleration, that's the derivative of the velocity. Okay, so that's the derivative of velocity. The derivative of velocity is just the slope. So let's look back at t equals 4. So at t equals 4 right here, is that slope going to be positive or negative? In other words, is my velocity increasing or decreasing? So I can explain this 2 ways. So first of all, the acceleration is negative. Now, it is negative, I know this, because, and you can write this in 2 different ways. You can say velocity is decreasing, or the slope of v at 4 is negative. Sorry, negative didn't quite fit. So whichever way you want to explain it, they both mean the same thing. Number 4, what is the average acceleration of the particle over the interval from 2 to 4? So let's talk about what the average acceleration is going to be. The average acceleration is going to be the velocity at 4 minus the velocity at 2. So the change in speed divided by the change in time. So that's going to be my average acceleration. So I'd already calculated v of 4, and I got that to be 6. And then v of 2, must scroll up and look at my graph. V of 2 looks like it's at 9. And so I have 6 minus 9 divided by 2, and that gives me an average acceleration of negative 3 over 2. This is acceleration, so that's going to be meters per minute squared. I believe our units are meters. Nope, feet per second. My fault. Feet per second. So my units are going to be feet per second squared. So that's my average acceleration. Number 5, is there guaranteed to be a time in the interval between 2 and 4, same interval I was working on, such that my derivative of v, or the acceleration, is equal to negative 3 over 2. So what we need to look at is v, and is v continuous, and is v differentiable. So I'm going to scroll back up so we can see the graph. V is continuous. That part I'm positive of. Continuous. No doubt in my mind. The question is it differentiable? And I'm going to go out on a limb and say between 2 and 4, which is right here, the answer to that is no. It's not differentiable at time is equal to 3 because there's a cusp, which means as long as my velocity is not differentiable, I cannot conclude that there's guaranteed to be an acceleration equal to negative 3 halves. So no, velocity is not differentiable at t equals 3 because of the cusp. Okay, because of that, A is not continuous. So there's no guarantee. I don't know how to spell guarantee. That's not it. There's only one R, I think. We'll go with there's only one R. We'll try that. There's no guarantee that A will equal negative 3 over 2 over the time interval 2 to 4. So look at us getting all these theorems in again. Such fun. Okay, moving on to the next one. I'm going to look at the graph while I read the question because the question's on the next page. So for number 6, at what time t in the given interval is the particle farthest to the right? And explain your answer. So let's talk about what's going on. This is my velocity, this is my derivative, and across this time frame right here, my velocity is positive. Okay, so from between 0 and 5, my velocity is positive, which means my x is increasing. Okay, my velocity is the derivative. After 5 until 9, my velocity is negative, which means my position is decreasing, moving to the left. So again, increasing means moving to the right. Moving right. This one means moving left. So when I want to know where is it to the right the most, that's going to be right at this point because of all of the increasing velocity. Sorry, the positive velocity means my object is moving to the right. That would be corresponding to increasing. So we can say that now. I'm going to move now to question 6. So in question 6, it would be at t equals 5 seconds, and v changes from positive to negative at t equals 5. And v is negative after t equals 5, creating a max. Again, relating that to our last unit. So moving on, we have our last example. Hang in there, we're really almost finished. It's not too much more. So what I would actually like for you to do is I'd like for you to try number 1 right now. So pause the video and try number 1 of example 3 now. Here's the solution. It is moving to the right because my velocity is positive. If you need to write some of that down, pause the video here. Number 2, the t equals 1 is the velocity of the particle increasing or decreasing. So the way that I would decide about increasing or decreasing is I want to know, is v prime positive or is v prime negative? So I need to take the derivative of v. When I take the derivative of v, that's actually my acceleration. So my acceleration is 6t minus 12. And the question is, at 1, is my acceleration positive or negative? So when I plug that in, I get a negative number, which means my velocity is decreasing. And that's because my acceleration is negative. Number 3, find all values of t for which the particle is moving to the left. So I would like for you to try number 3 of example 3. So please pause the video now and do that one. Here's my solution. I have that the object, the particle, is moving to the left when time is between 1 and 3, and that is where the velocity is negative. So if you need to make any corrections or finish that problem, pause the video now so that you can do that. Moving on to number 4. Number 4 is, okay, find the total distance traveled by the particle in a time interval from 0 to 5. And guess what I want you to do? Yes, you are right. I want you to finish off this worksheet by doing number 4. So please pause the video now and complete the last problem. No, really. No, really. Do the last problem. Like, really, do the last problem. I got 28 units, so if you did too, you are finished. Have a nice evening. If you did not get 28 units, you need to pause the video here and see if you can work out how I got 28 units. Please be sure and write down any questions that you have on the video lesson, and have a wonderful evening.